Alkanes are homologous series. A homologous series is a family of compounds with the same general formula and similar chemical properties. All of these molecules here are homologous series, but we'll be focusing on alkanes in this lesson. Alkanes are a group of hydrocarbons because they only contain two types of atom, carbon and hydrogen, as you can see in these examples here. As I mentioned, each homologous series has the same general formula, and the general formula for alkanes is CnH2n add 2. Here's our homologous series of alkanes going up to octane, and we've got some new terms here. So molecular formula simply tells us how many carbons and hydrogens are in each alkane and nothing else. You can see that each molecular formula fits the general formula because for each carbon there are 2 hydrogens plus 2 more, like here with ethane. So we've got two carbons times 2 is 4 and add 2 is 6, so we've got 6 hydrogens, and that fits this formula here. The full structural formula is the proper arrangement of the atoms, and you would draw this when you're looking at the reactions of hydrocarbons, because then you can see which atoms are moving where. And then finally we've got the shortened structural formula, which is similar to the full structural formula, but it doesn't show how each hydrogen is attached to each carbon. It does look a little bit like molecular formula, but more complicated because it tells us more about the molecule because we can determine the structure of the alkane from it. Here are alkanes again, and we're going to talk about naming them now. These types of alkanes are fairly easy to name due to their prefixes, so all you have to do is count the number of carbons and then put the correct prefix on ane. So these prefixes are very important to learn. Here's an example. So you'll start by counting the number of carbons in the chain, and there are 5. So that means that the correct prefix is pent, which makes this molecule pentane. What we have looked at so far are called straight chain alkanes because the chain of carbons did not have any carbon branches. The other type of alkanes that we will look at do, which is why they're called branched alkanes. As you can see in this example, branched alkanes still fit into the general formula, but this molecule is not heptane. The naming of branched alkanes has a number of steps to ensure that their name correctly describes their structure so that a scientist knows where about the branches on the molecule and how many carbons are in it. We're going to name this branched alkane using a 3-step process. Number 1, you need to identify the longest continuous chain of carbons. This can often be the longest straight chain like it is here, but this isn't always the case. So this straight chain has 6 carbons in it, so the backbone is hexane. Now we have to number this chain so that we can determine which carbon the branch is on. We're going to always number these carbons from the side nearest the chain. So in this case, carbon 1, carbon 2, carbon 3, the branch is on carbon number 3. Now we need to determine how many carbons are in the branch and the name for it. So because there's just 1 carbon in this branch, the prefix is meth. To put this all together, the branched alkane is called 3-methylhexane. We will use a similar process to draw molecules from their name.